Welcome to Automated Visual Software Analytics. This part is about analytics. We will briefly introduce big data and big data analytics, as well as we will have a look on analytics examples. Let's start with big data. Big data is one of the most important catchphrases used today in IT systems engineering, IT technology, and IT solutions. Data is the new oil, as it is quoted here. Data is just like crude. It's valuable, but if unrefined, it cannot really be used. This somehow summarizes the challenges behind big data. Big data needs to be refined. Let us first look at some sources of big data. For example, all kinds of sensors deliver constantly a large amount of data, for example, in early warning systems, automotive systems, or assembly lines. Also in business processes, more and more we get data in real time about transactions, logistics, finance, or stock exchange data. In communication and digital footprints, we find big data as well, for example, in the context of smartphone usage or media streaming. Also, in the scope of customer and customer-related applications, we get large amounts of data, for example, from online shopping or due to position tracking of customers. Of course, science and research also produce data, like, for example, in biology or chemistry, protein folding simulations is maybe one of the big examples here. And finally, software development. Software development produces large amounts of data as well. This data typically is stored, for example, in software repositories, in the source code base of legacy systems, or in general of every large software project. What are the characteristics of big data? We can summarize the characteristics by a list of the following aspects that are typical for big data. It's, of course, the volume, a high data volume typically measured in terabyte, petabyte, or even zettabyte. It's also the velocity. That means the speed at which data is generated, at which data streams and data flows take place. Another aspect includes variety. That means the diversity of the structure that characterizes big data. Sometimes it's structured, sometimes it's semi-structured, and frequently it's also unstructured. Another aspect includes variability. That means the data flows, the data delivery may be inconsistent. Also, the flow rates may be different over time. Another aspect includes complexity. Complexity means within big data we find manifold links, relationships, and correlations among the data. Finally, another aspect includes veracity. That means in big data we typically have a certain degree of uncertainty, imprecision, and incompleteness. This more or less are defining criteria for big data. So what about analytics for this kind of data? Big data, of course, it's difficult to handle big data. It's difficult to get insights into big data. Analytics helps us to explore, to analyze big data. What is the difference to traditional analytics? In traditional analytics, we have basically a structured and repeatable process. So we build structures that allow us to store data. And from the perspective of the process, we typically start by creating a hypothesis. We formulate questions, we request data, we analyze information, and we get hopefully answers to verify, to falsify our hypotheses. So we start with the hypothesis and test against selected data. This is the traditional analytics approach. In big data analytics, there's a key difference. In big data analytics, we start with the data and explore the data without selecting specific parts of the data. So we explore the entire data set. We try to find correlations, to find interesting patterns or structures, and hopefully this gives us some actionable insights. So the data leads the way we work with challenges, with tasks that we have to fulfill based on big data. So we explore all the data and we identify correlations in this approach of big data analysis. And this process is also called iterative and exploratory because we repeat several times this process until we find the right insights. The data is a structure here, so we do not have a specific structure to which data is mapped. We keep the data as it is, it's big data, so we have to find good ways, efficient ways to directly operate on big data. Yeah, so if we ask who delivers what, we find out that in traditional analytics, the users first determine and specify what they want to see, what they want to explore, and the IT systems select and deliver data that is then explored. So it's analyzed after landing, in a way. In big data analytics, in contrast, the IT solutions, the IT systems have to deliver data from any sources, from any platform, and the users start working with that data, asking, exploring questions. So we analyze while the data processes, the data flows are in motion. That's the key difference between traditional analytics and big data analytics. Now, let us try to define analytics more precisely. What we have seen is there's an increasing amount of large, dynamic, heterogeneous, distributed and complex data around. And of course, such data, big data, raises the question, how can applications, systems and users actually use that kind of data? How can we take advantage of big data? If it is stored, it's still not used. So we have to fill this gap as well. Analytics provide effective means to explore, analyze, and use big data. Analytics also aims at providing methods, techniques, and tools that enable to efficiently get insights into big data, actionable insights, to uncover structures and patterns, as well as to acquire knowledge by reasoning. So these are the principal tasks that are done by analytics or big data analytics. The objectives of analytics include the following points. With analytics, we hope to discover what is happening, what is ongoing in processes in our business, in the software development, for example. We want to determine why it is happening, and of course, we also would like to predict what is likely to happen and to prescribe the best action to take. Analytics is also about convert data-driven insights into meaningful actions. This is what comes when we apply analytics. Why do we apply analytics? Because we want to convert data-driven insights into something that makes sense in the concrete context of our application or system. We want also to drive smarter decisions, enable faster actions, and optimize outcomes. This comes from IBM Analytics, a blueprint for value. But it summarizes in a few words what is the key point in analytics. Why should we apply analytics? Yeah, let me give some examples. The word analytics is now used in a number of domains that are even known to the general public. For example, if we talk about web analytics or Google Analytics, or a flurry analytics for the apps and app usage, or in the realm of software engineering, software diagnostics and their approach to software analytics. Yeah, these are just 4 examples. As you can see, they are different domains. So analytics equally applies to the fields of finance, to medicine and health, as well as to the web or to software engineering. This course will focus, of course, on software engineering and analytics specific to software engineering. Yeah, to make clear what is the difference between analytics and analysis. Both terms are quite similar, but we should, of course, differentiate between both terms as they denote 2 completely different things. Analytics includes a number of disciplines, among them mathematics, statistics, methods for data gathering, data mining, and information visualization, descriptive as well as predictive strategies. So it's a multidisciplinary approach. It's operating on an algorithmic basis rather than by heuristics. It derives and delivers quantitative information, and it's a formal and repeatable process. So this characterizes analytics. Contrast, analysis denotes the systematic examination of a structure, composition, and meaning of a more complex issue. Typically, it's based on heuristics. It's an informal and qualitative process. The goal of analysis is to uncover and understand interrelationships or cause-effect relationships. So, analysis typically provides basic elements, building blocks that are used to build analytics solutions. And it's, of course, a basis for problem solving and decision making. In a sense, analysis approaches are used by analytics, but analytics is much more. It combines different analysis techniques to form more complex solutions that aim at giving insight into a complex subject, into a complex data set, such as in the case of big data. What are the challenges in analytics? In the scope of analytics, we have a number of different challenges. For example, the data variety causes a number of problems. Analytics here requires access to a variety of different data sources, typically stored differently, organized differently, and managed by different technologies. Data volume represents a big challenge as well. Large, massive data sets demand for efficient access and compact storage, such as based on out-of-core external memory algorithms or in-memory databases. The unstructuredness causes some challenges. For example, if it differs from structured data in that its format varies widely and cannot be stored due to this in traditional relational databases. And of course, data velocity represents a big challenge. To be effective, analytics need to find ways to perform analytics computations in real time, or at least in nearly real time. That is, also tools and techniques for analytics have to find ways to extract, transform, analyze, and visualize, so to do all these steps in real time or nearly real time. Yeah, these are the challenges. Let's summarize this part. We have seen that analytics represents a major development direction, providing means to effectively use and to take advantage of big data. The paradigm behind big data analytics is different to the paradigm in traditional analytics. Big data analytics takes into account the entire data, allows for exploring large data, and provides means to analyze the entire data set. Today's software development processes and software engineering techniques generate big data as well about the system, its source codes, its dynamic, and its evolution. For software analytics, therefore, principles, concepts, methods, and techniques of analytics can be extended, enhanced, and specialized to get analytics instruments and tools that facilitate to get decision-supporting insights into software development processes and, of course, into complex computer-based systems. Yeah, this concludes this part, and let us have a look on some terminology. We have introduced the term big data, defined by referring to data that is characterized by its high volume, high velocity, high variety, high variability, high complexity, and inhomogeneous veracity. Big data demands cost-efficient and time-efficient approaches of storing and processing, for getting insights and decision-making. As a catchphrase, it is used to describe both big data itself and, of course, all related technologies that allow to efficiently handle and manage big data. Analytics. Analytics is the science of analytical reasoning that aims at providing concepts, methods, techniques, and tools to efficiently collect, organize, and analyze large sets of data, such as big data. Its objectives include to examine data, to draw conclusions, to get insights, to acquire knowledge, and to support decision-making. Contrast analysis refers to the examination of a complex, its elements and their relations, opposite to synthesis in a sense. Analytics solutions typically apply, use, and integrate different analysis techniques as kind of building blocks. As further reading, I can recommend this report from IBM entitled Analytics, a Blueprint for Value. It's available as PDF. Let me give them two short remarks at the end of this part. Big data analytics is considered to be the next key innovation way, even an innovation wave in both industry and science, but there is not too much analytics for software engineering today, both theoretically and practically. So it's a key challenge as well for software engineering to adopt and apply, to enhance and extend big data analytics techniques for software engineering questions and challenges. Analytics will be one of the key game-changing technologies in software engineering in the future. And this course basically is exactly about this kind of analytics called software analytics.